Definition: sound is a form of energy that produces a sensation of hearing in our ears. The law of conservation of energy states, sound energy can neither be created nor destroyed, only converted from one form to another. Sound is produced by vibrating objects. Vibration means a kind of rapid to and fro motion of an object. Human voice is produced due to vibrations in the vocal cords. A buzzing bee or a flapping bird wing produces sound through vibration. Plucking a stretched rubber band creates sound through vibration. Striking a tuning fork sets its prongs vibrating, producing sound. Tuning fork experiments. When a vibrating tuning fork touches a suspended table tennis ball, the ball is pushed away. This proves that the prongs are in motion, vibrating, when they touch the ball. When the prongs of a vibrating tuning fork are dipped in a glass of water, it creates a splash. The splash and surface ripples visually demonstrate the vibrations transferring to the water. Medium, the matter or substance through which sound is transmitted, is called a medium. The medium can be solid, liquid, or gas, through which sound travels. A vibrating object sets the surrounding particles of the medium into vibration. These particles do not travel all the way to the ear. Instead, they exert a force on adjacent particles. Displacing them, the particles then return to their original rest position after the disturbance. This creates a wave, a disturbance moving through a medium where particles set neighboring particles into motion. Because sound requires a medium to travel, sound waves are called mechanical waves. When a vibrating object moves forward and backward in the air, it creates variations in pressure, compressions, C, regions of high pressure and high density where particles are crowded together. These regions are created when the object pushes forward during vibration. Rarefactions, R, regions of low pressure and low density where particles are spread apart. These regions are created when the object moves backward during vibration. Sound waves are longitudinal waves. Longitudinal waves are waves in which the individual particles of the medium move. They move in a direction parallel to the direction of propagation of the disturbance. Sound waves are longitudinal waves because particles simply oscillate back and forth about their position of rest. This is exactly like a pushed and pulled slinky toy demonstrating sound wave behavior. In transverse waves, particles oscillate up and down, perpendicular to the direction of wave propagation. A sound wave can be described graphically by tracking density and pressure variations. A peak on the graph is a crest, compression, and a valley is a trough, rarefaction. Wavelength is defined as the distance between two consecutive compressions, C, or two consecutive rarefactions, R. Wavelength is represented by the Greek letter lambda, and the SI unit is the meter, M. Frequency is defined as the number of complete oscillations per unit time. The SI unit for frequency is the hertz, named after HR, Hertz. Pitch is determined by faster vibrations, which mean higher frequency and higher pitch. The time period T is defined as the time taken for one complete oscillation. It is also the time taken for two consecutive compressions or rarefactions to cross a fixed point. The symbol for time period is T and the SI unit is the second, S. A is defined as the magnitude of the maximum disturbance in the medium. Loudness or softness of a sound is determined by its amplitude. A larger amplitude results in a louder sound because it carries higher energy. Higher energy sounds can travel larger distances compared to softer sounds. Quality or timbre is the characteristic that allows us to distinguish between two sounds. Two sounds can have the same pitch and loudness but still sound different. A single frequency sound is referred to as a tone, while a pleasant mixture is a note. The speed of sound is much less than the speed of light. This is why we hear thunder after seeing lightning during a storm. The speed of sound depends on the properties and temperature of the medium. Speed is fastest in solids, slower in liquids, and slowest in gases. As temperature increases, the speed of sound also increases. In air, the speed is 331 meters per second at 0 degrees Celsius and 344 meters per second at 22 degrees Celsius. Sound bounces off solid and liquid surfaces just like light does. It follows the same laws of reflection as light does. The direction of incident sound and reflected sound make equal angles with the normal. The incident sound, normal, and reflected sound all lie in the same plane. An echo is defined as a distinctly heard reflected sound. The sensation of sound persists in our brain for 0.1 seconds. To hear an echo, the time interval must be at least 0.1 seconds. At 22 degrees Celsius in air, the sound must travel at least 34.4 meters total. This makes the minimum distance to the obstacle 17.2 meters. Echoes can be heard multiple times due to multiple reflections. This is similar to the rolling sound of thunder bouncing off clouds and land. Reverberation is the repeated reflection of sound in a big hall. This results in a persistence of sound that can be undesirable. Excessive reverberation is reduced by covering roofs and walls with sound-absorbent materials. Materials like compressed fiberboard, rough plaster, or heavy draperies can help. Megaphones and horns are designed with a conical opening to guide sound waves. This design helps to direct sound forward in a specific direction without spreading. A stethoscope is a medical tool that guides the patient's heartbeat sounds. The sounds are guided to the doctor's ears through multiple reflections inside the tube. Concert halls often have curved ceilings to ensure sound reflects evenly. This design helps sound reach all corners of the hall effectively. Audible range. For average humans, the hearing range is 20 Hz to 20,000 kHz, 20 kHz. Infrasound, infrasonic, sound frequencies below 20 Hz. Examples: vibrations of a pendulum, rhinoceroses communicate at 5 Hz, whales, elephants, and early earthquake shock waves. Ultrasound, ultrasonic, sound frequencies above 20 kHz. Examples: produced by dolphins, bats, porpoises, rats, and some moths to navigate and avoid capture. Hearing aids, battery-operated devices for people with hearing loss. They use a microphone to convert sound to electrical signals, an amplifier to boost them, and a speaker to convert them back into clear sound for the ear. Ultrasounds are extensively used in industry and medicine. They can travel along well-defined paths, even around obstacles. Cleaning, used for hard-to-reach parts, spiral tubes, electronic components. The object is placed in a cleaning solution, and high-frequency ultrasonic waves detach dust and grease, detecting flaws in metals, used in building structures and bridges. Ultrasound is passed through metal blocks. If there is a crack or hole, the waves reflect back to a detector. Ordinary sound cannot be used as its longer wavelengths bend around corners. Echocardiography. Ultrasonic waves reflect off heart parts to form an image of the heart. Ultrasonography, used to image internal organs, liver, gallbladder, kidneys, uterus, to find stones or tumors. It works by reflecting waves off regions with varying tissue densities. Surgical use. Ultrasound can break small kidney stones into fine grains so they can be naturally flushed out.